want to start today with a feeling, a really specific feeling that I think everyone listening knows.
Okay.
It's that moment when you are staring at your computer, you have like a 3-sentence email to write, and it feels like your brain is physically wading through cement.
Oh, that is such a vivid description.
Yeah.
The cursor is just blinking, and you know what you need to say, but the wires just aren't connecting.
Exactly. And it's not just being tired. It's this weird mix of, exhaustion, irritability, and just fog. My patience is basically gone, and I can't focus on anything. And usually I start blaming things. Blame my bad sleep or maybe that heavy lunch I had, or I just go, oh, I'm just getting older.
We all do that. We look for the most obvious physical suspect.
But I've been reading through this stack of research you sent over for our deep dive today, and it looks like I've been blaming the wrong things entirely. These sources point to something much, much sneakier.
They do. We're looking at a collection of papers today all about neural architecture. And the central argument is that what you're describing, that wading through cement feeling, isn't just a mood. It's the result of a very real chemical chain reaction.
One of the articles used a word that really stuck with me. Poison?
It sounds dramatic, doesn't it? But when you look at the neurobiology, it's actually pretty accurate. We aren't talking about, the acute stress of a big deadline on Friday.
Or a tiger chasing you.
Right, not the tiger. We are talking about chronic low-grade stress, the traffic, the bills, the news cycle, the phone buzzing in your pocket every 15 seconds.
That sort of simmering background noise of modern life.
Precisely. And the research argues that this constant simmering is triggering a response that is silently and very slowly rewiring your brain's chemistry. It's physically changing the structure of your brain while you sit there.
So, okay, our mission today is to expose that poison. We're going to look under the hood at the neuroscience of what stress is actually doing to us. And because we aren't here just to scare everyone, no, definitely not.
We're going to talk about the antidote.
And there is an antidote. That's the most important part of this whole conversation. The process is reversible, but you can't fix the machine if you don't understand how it's breaking.
So let's start with the mechanism. If this is a poison, what's the actual toxin? The papers all kept coming back to one specific chemical we've all heard of.
Cortisol.
Right. The stress hormone.
It is, but I think we need to reframe that a bit. Cortisol isn't inherently bad. Not at all. It's actually a vital part of a very ancient, very sophisticated system in your body called the HPA axis.
Okay, that sounds like a lot of syllables. Break that down for us.
It stands for the hypothalamic pituitary adrenal axis. But, you can just think of it as your body's emergency command center.
The command center. Got it.
Yep.
So how is it supposed to work? In a perfect world.
Well, let's go back to the world we evolved in. Let's say you're a hunter-gatherer, you're walking through the tall grass, and suddenly a twig snaps. You see a tiger.
Survival mode. Your HPA axis just lights up instantly. It starts pumping out cortisol. And in that moment, cortisol is a hero. It floods your bloodstream with glucose for energy. It sharpens your focus to a razor's edge.
And it shuts down anything non-essential.
Exactly. Digestion, immune response, anything that can wait. It prepares you to either fight that tiger or run for your life.
Which is what you want.
It saves your life. And then once you escape, you get back to safety, you relax, and your cortisol levels drop right back down. The system resets.
But I don't see a lot of tigers in my daily life.
And that is the absolute crux of the problem. This is what evolutionary biologists call a mismatch. Our biological hardware is ancient, but our cultural software is brand new. Your HPA axis, it's like a smoke alarm that can't tell the difference between a house fire and burnt toast.
So it treats a passive-aggressive email from my boss with the same chemical intensity as a predator.
Biologically, yes. The initial physiological kick is shockingly similar. But here's the problem. The tiger eventually leaves.
The emails never stop. The financial worry doesn't go away.
Exactly. So the alarm never shuts off. It just becomes this relentless drip, drip, drip of cortisol. And that constant bath of stress hormones is what turns cortisol from a hero into a toxin.
It's the duration, not the intensity.
That is what does the damage.
And the sources get pretty graphic about what this drip does to the brain physically. It's not just a feeling. We're talking about actual physical damage.
Oh, it's a full-on assault on your neural architecture. And it's very targeted. The first casualty is almost always the hippocampus.
And that's our memory center.
Correct. tucked away in the temporal lobe. It's crucial for learning, for memory, for context. The problem is the hippocampus is just covered in cortisol receptors.
Yeah.
It's incredibly sensitive to this hormone.
So when we're flooded with stress, the hippocampus takes the brunt of it.
It does. I mean, the data shows that high chronic levels of cortisol actually inhibit neurogenesis.
Neurogenesis. Okay, that's the creation of new brain cells. Right?
Exactly. Stress literally stops you from growing new brain cells.
Yeah.
But maybe even worse, it can cause the existing neurons to atrophy. They shrink.
Wait, they physically get smaller.
Physically smaller. The connections between them wither. So if you've been chronically stressed and you suddenly can't remember where you put your keys, or you're trying to learn some new software at work and it just won't stick.
You shouldn't beat yourself up.
No, it's your hippocampus physically struggling to function under that chemical weight. It is shrinking your ability to process new information.
That is genuinely terrifying. But while the memory center is shrinking, there's another part of the brain that's doing the complete opposite, isn't there?
Yes, and that is the cruel irony of neuroplasticity. While the hippocampus withers, the amygdala, the brain's fear center, gets supercharged.
This is the part that handles that fight or flight instinct.
That's the one. Under chronic stress, the amygdala becomes hyperactive. It actually grows larger and forms stronger, more efficient neural connections. It's like a muscle that's being worked out 24/7.
So you get better
Yeah.
at being afraid.
You get better at threat detection. You start seeing danger and negativity everywhere. A neutral comment from a partner feels like an attack. A glance from a stranger feels like a judgment.
So, okay, you've got a shrinking memory center and this like hulking bodybuilder fear center. That sounds like a recipe for disaster.
And it gets worse when you look at the third player here, the prefrontal cortex. Think of this as the CEO of the brain. It's for logic, impulse control, long-term planning. It's the adult in the room.
And I'm guessing cortisol doesn't do great things for the CEO.
Not at all. It weakens the connections in the prefrontal cortex. It effectively takes the CEO offline.
Okay, so let me try to put this all together. If I'm under chronic stress, my emotional reactive brain, the amygdala, is screaming.
At top volume.
My memory center is struggling. And the logical part of my brain, the part that's supposed to say, hey, let's calm down, has been disconnected.
You have nailed it. And that explains so much of the behavior we regret later. Why you snap at your kids over nothing, why you eat an entire bag of chips when you told yourself you wouldn't. The part of your brain that says, maybe we shouldn't do this, is literally on mute.
It feels like a loss of control because biologically, it is a loss of control.
You are operating on pure reactive instinct.
Okay, so that's the structural damage. The hardware is breaking. But the deep dive into this research gets even more granular. It's not just the buildings crumbling, it's the chemicals running through the pipes.
This is where we see why you feel the way you do. Stress just wreaks havoc on the neurotransmitters, the messengers that regulate your mood.
Let's start with the big one, serotonin. Everyone calls it the happy molecule.
Right. Serotonin regulates mood, sleep, appetite, but chronic stress is like a signal jammer. It interferes with your brain's ability to produce it. But there's a nuance here that really struck me. Stress can also reduce the sensitivity of the receptors that are waiting to catch the serotonin.
So even if your brain is making some, you can't hear it.
Exactly. It's knocking on the door, but no one's home. And that's a direct biological path to low mood and anxiety.
And then there's dopamine, the motivation chemical.
This one is so interesting. Acute short-term stress can actually boost dopamine. It's that rush you get before a deadline. But chronic stress, it just burns the whole system out. It desensitizes your reward circuitry.
The sources used a specific term for this. What was it?
Anhedonia.
Anhedonia, right?
It's the inability to feel pleasure. It's that profound sense of blah. You know, you usually love playing guitar or going for a run, but suddenly you just can't be bothered. There's no joy in it.
That's not laziness. That's your dopamine system malfunctioning.
Yes, precisely. And then there's GABA. GABA is your brain's brake pedal. Its whole job is to calm the nervous system down. Stress weakens GABA signaling. It basically cuts the brake lines.
So the engine is revving, but you can't stop. That explains that tired but wired feeling. You're exhausted, but your thoughts are just racing.
100%. But if we want to talk about true toxicity, we have to go one level deeper and talk about glutamate.
I saw this. I usually think of neurotransmitters as, good things. But this part of the research was alarming.
Well, glutamate is your brain's main go signal. It's an excitatory neurotransmitter. It's essential. But cortisol triggers a massive surplus of it.
Too much gas in the engine.
Way too much gas. And in the brain, too much excitation is toxic. The sources call it excitotoxicity.
What does that actually do to a brain cell?
It creates these things called free radicals, unstable molecules, and the research vividly describes them as punching holes in your brain cells. It revs the neurons so hard that they literally burn out and die.
Wow. So we're talking about brain cells literally dying because they're being overstimulated by stress.
Yes, and at the same time, stress is depleting something else called BDNF, brain-derived neurotrophic factor.
The researchers call that fertilizer for the brain.
It's the perfect analogy. BDNF helps you grow new neurons, keeps the old ones healthy. Stress just drains the tank. And low BDNF is linked to depression and even a higher risk of dementia later in life.
And just to add one more layer of horror before we get to the solution, I read about a leaky barrier.
The blood-brain barrier.
Yeah.
It's like the fortress wall that keeps toxins and viruses out of your brain. Chronic stress makes that wall more permeable. It makes it leaky.
Letting things in that shouldn't be there.
Exactly. Pathogens, inflammatory markers. And this activates the brain's immune system, which causes neuroinflammation. You know that wading through cement feeling we started with?
Yeah.
That's very often neuroinflammation. Your brain is literally physically inflamed.
Okay. I have to be honest. I'm feeling a little stressed just listening to all this. We have a shrinking memory, a raging fear center, an offline CEO, holes being punched in ourselves, and a leaky wall. It feels hopeless.
It does feel heavy. But this is the pivot point. This is why we do this deep dive.
Because there's an antidote.
Crucially, yes. The sources all emphasize that this damage is not permanent. The brain is incredibly plastic. It's resilient. You can rebuild the hippocampus. You can calm the amygdala. You can bring that CEO back online.
But you have to be active about it. The research used the phrase active architect.
Exactly. You can't just wait for the stress to stop. You have to build defenses. And the research outlines 4 specific, powerful antidotes.
Let's walk through them. Step 1 is something I know I'm terrible at. Sleep.
But we have to reframe sleep. We think of it as just resting. The science says sleep is actually a deep cleaning cycle.
A cleaning cycle.
Yes. There's something called the glymphatic system. Think of it like a night janitor for your brain. When you sleep, your brain cells actually shrink a little, and this system flushes out all the metabolic waste.
And it washes away the extra cortisol.
That is the key. It clears out the excess stress hormones that have built up all day.
So getting 7 to 9 hours isn't a luxury. It's a non-negotiable biological reset.
It really is. If you cut sleep short, the janitor doesn't finish the job.
Yeah.
You start the next day with yesterday's toxins still sloshing around. You're starting the day already inflamed.
Okay, so sleep cleans out the toxins. What's step 2? How do we fix those broken brake lines on that racing mind?
Mindfulness and breath work.
Now, I know when people hear mindfulness, they sometimes think of, humming on a mountaintop. It can feel a bit soft.
I get that skepticism, but the sources are very specific about the biology here, not the spirituality. When you do deep, slow belly breathing, you aren't just relaxing. You are physically stimulating the vagus nerve,
Which connects to the parasympathetic nervous system.
the rest and digest mode. It is the direct physiological opposite of fight or flight. By controlling your breath, you are manually overriding the HPA axis. You're sending a physical signal to your brain that says, we're safe, you can stop pumping cortisol now.
So it's like hacking the system from the inside out.
You're using your body to tame your brain. It calms that supercharged amygdala almost instantly.
I like that. More tactical. Okay, step 3. We need to get the CEO, the prefrontal cortex, back online. And we need more of that fertilizer.
And the best tool for both of those is exercise.
Just moving your body.
Yes. Physical activity is the most effective way we know to boost BDNF production. When you move, you signal your brain to produce more of that growth factor.
Does this mean I need to start training for a marathon?
No, and that's the beauty of it. The research shows that even just a brisk 30-minute walk is enough. The goal is to get the blood flowing. It helps clear cortisol, and it stimulates that neurogenesis in the hippocampus. You are literally regrowing the parts of the brain that stress shrunk.
You can walk your way to a bigger brain. That's really empowering.
It is. It puts the control right back in your hands.
All right, step 4. We've cleaned the brain, calmed it, and fertilized it. Now we need the raw materials. Nutrition.
Your brain is a chemical factory. It can't build neurotransmitters out of thin air. It needs ingredients.
The sources highlighted 2 main categories: antioxidants and amino acids.
Right. Remember those holes being punched in cells by the free radicals?
The excitotoxicity, yeah.
Well, antioxidants, which you find in berries, leafy greens, dark chocolate, they are the shield. They neutralize those free radicals. They patch the holes.
And the amino acids.
Those are the actual building blocks. For example, your brain needs an amino acid called tyrosine to make dopamine. It needs tryptophan to make serotonin. If you're not eating enough protein with these in it, your brain physically cannot manufacture the mood chemicals you need.
So eating a salad with some chicken on it isn't just dieting, it's actually restocking your brain's arsenal.
Exactly. You are giving your brain the resources it needs to fight back against stress.
This really changes the whole narrative, doesn't it? We think of stress as something that just happens to us, like bad weather.
But the science shows us that while the stressor might be external to the job, the traffic, the reaction is internal, and it's manageable. You are not a passive victim of your brain chemistry.
You are its active architect.
That is the key takeaway. Modern life is arguably designed to poison your brain. It just is. But you have the architectural plans to reinforce the structure.
So let's wrap this. We've gone from the invisible poison of cortisol to the shrinking hippocampus and the offline CEO, all the way to these simple, powerful antidotes of sleep, breath, movement, and food.
It is a journey from vulnerability to agency. I think the most dangerous thing about stress is that feeling of helplessness. And the science says you are not helpless.
So here's the question for you, listening right now. We don't want you to be overwhelmed by trying to do everything at once. That would just be more stress.
Right. Don't try all four, just pick one.
What is the one antidote you can use today? Is it setting a strict bedtime tonight? Is it taking 5 minutes to do deep belly breathing before you open your inbox? Or is it putting on your shoes right after this and going for that 30-minute walk?
Just choosing one signals to your brain that you are back in control. You're putting the CEO back in the chair.
The poison is slow, but the antidote is powerful. You can reclaim your mind. Thanks for diving deep with us today.
Now go take that walk.
We'll see you next time.